Covalent bonding, dot and cross diagram. Covalent bonding is the second type of bonding where you can find this type of bonding between non-metal atoms. They form this bond by sharing the electrons instead of the movement of electrons between from one atom to another, so there is no formation of ions here. The bonds is formed by the electrostatic interaction between the positively charged nuclei of the two atoms and the shared electrons. This is why covalent bonds are very strong because of this very strong electrostatic interaction. Covalent bonding is a share of pair of electrons between two atoms. So each covalent bond comes from a share of pair of electrons, one electron from each atom. When the atoms share their electrons, they try to reach the full outermost shell of electrons. So if an atom has a certain number of electrons in its outer shell, let's say 6 for example, they will need two extra electrons in order to reach the full outermost shell. So they will share two pairs of electrons to reach this 8 or this full outermost shell. So let's have some examples of how to draw the covalent bond. To draw the covalent bond, we will use the dot and cross diagram. The dot and cross diagram is very useful for showing which atoms the electrons in a covalent bond come from. In your specification, you need to learn drawing the dot and cross diagram for certain molecules. These molecules we're going to show right now. The first one is hydrogen. When you draw the covalent bond using the dot and cross diagram, you have to do two things or take two things into account. The first thing is the relative size of the different atoms that share the electrons. So hydrogen is a molecule that is a biatomic molecule that is the bond between the two hydrogens come from sharing one pair of electrons between the two hydrogens. Of course, the two hydrogens have the same size, so when we draw them of the same size. To show the electrons that are shared, we need to have an overlap between the two outermost shells for the two hydrogens or the two atoms and both the pair of electrons in the middle. So one of them is in the form of a dot and the other one is the cross. So each electron comes from a different atom. So this is for hydrogen, hydrogen H2, one bond is formed by the share of one pair of electrons. The second molecule is hydrogen chloride. As you can see here, when we consider the relative size, hydrogen is in period 1, which means hydrogen has only one outermost shell of electrons, while or one shell of electrons, while chlorine is in period 3, which means each chlorine atom has three shells of electrons. So the size of chlorine is almost triple the size of hydrogen, and we will consider that when we draw the hydrogen chloride. Chlorine has 7 electrons in its outermost shell, and so chlorine will need only one electron in order to reach the complete or the full outermost shell of 8 electrons. Hydrogen has only one, but hydrogen has only also one electron shell, and this is the first electron shell, so the maximum capacity of this is 2 electrons. So hydrogen and chloride will share, and chlorine will both share a one pair of electron in between the two of them. The dot here represents the electron coming from the chlorine, and the cross is the electron coming from the hydrogen. Don't forget to draw all the other electrons in the outermost shell of the chlorine, which does not take part in the covalent bonding. The third molecule is oxygen. Oxygen now has 6 electrons in its outermost shell. Of course, the two oxygen will have the same size, so when we draw them, we will draw them in the same size. Each oxygen has 6 electrons in its outermost shell, so each oxygen will need 2 extra electrons in order to reach the full outermost shell. In order to reach this 8 full or most outermost shell, they will need to share in between them two pairs of electrons. We draw in between the area in between the two of them where there is an overlap. We will draw two different pairs of electrons. Each one of these will represent one bond. So between the two oxygen, there are two bonds, two covalent bonds are formed. Don't forget as well to draw also the electrons that are not shared on each oxygen atom. The fourth molecule is water. In water, oxygen again has 6 electrons in its outermost shell. It will need 2 extra electrons, so it will have to share 2 pairs of electrons. With hydrogen to form water, hydrogen is only able to share 1 pair each one, so there will be 2 different hydrogens bonded to the oxygen, while one pair of electrons will be shared with each hydrogen. 4 electrons on the oxygen are not shared. And this is the molecule of water. Remember that hydrogen is in period 1, oxygen is in period 2, which means the size of oxygen is almost double the size of the hydrogen. We also need to learn about carbon dioxide. Carbon dioxide is the molecule where one carbon atom binds to 2 oxygen atoms to give you CO2, which is carbon dioxide. Both carbon and oxygen are in period 2, so they almost have the same size in terms of the size of atoms. Carbon has 4 electrons in its outermost shell, so it will need 4 more electrons. So carbon will share 4 pairs of electrons. And oxygen has 6, so each oxygen will only share 2. So we will have the carbon with 2 different oxygen. With each one, there are 2 pairs of electrons. The dot here represents the electrons coming from the oxygens, and the crosses represent the electrons coming from the carbon. And finally, methane. Methane is a hydrocarbon, one of the organic molecule. In methane, we have one carbon with 4 hydrogens. The carbon is almost double the size of the hydrogen, and then we have the carbon has to share 4 pairs of electrons with 4 different hydrogens, because hydrogen will only share 1 pair of electron. So here we're gonna draw the carbon with 4 different hydrogen atoms with 1 pair of electrons with in the overlap area between the carbon and hydrogen. And this is how we draw the dot and cross diagram to represent the different covalent bonding. Remember that each pair of electrons represent one covalent bond. So if there's more than one pair, that means more than one covalent bonding